is a video to show how to get a prediction interval. We've been talking about trying to find some type of a relationship between the shoe print size and the height of an individual. And so I want to come up with a prediction interval. I'm going to go through and just do some of the other things that we're doing in this section just to show, for example, if I wanted to find the correlation. So the first thing I might do is say, well, what's the correlation coefficient? And I can do that with the equal, C-O-R-R-E-L, open a parentheses. It wants my data 1, so I highlight that, comma, and now my data 2, and then I close my parentheses. So I highlighted my, and this one doesn't matter. You're going to see other things like intercept and slope, those functions, the order matters, but this one doesn't. All right, so that's my correlation coefficient, which is pretty good, right? Linear correlation coefficient. Next, if I want to get my, look at my coefficient of variation, which is just r squared. So coefficient of variation, r squared. So I just take that value and I square it. So that's my actual explained variation in my height by my linear relationship between shoe print and height. All right, so then next I want to find, let me go ahead and just show you how to find the slope and the y-intercept. Most of you probably won't do these manually, but just so you know that you can. So equals slope, open parentheses. Notice this one wants the y values first. So this would be my height that I would highlight. And then I would highlight my x values. So I get my slope, press enter. And my y-intercept. This one, even though it's y-intercept, you just use the word intercept. And this one as well wants you to pick the y's first. So there's the y's, comma, and here are the x's. So I could actually write my regression equation right now. I was just looking at this going, hey, something's missing. I could write my regression equation right now based off of this information. So if I did, let's just insert a text box and insert my equation. So my predicted y then would equal my y-intercept, just round it, plus my slope times my variable that I actually would plug in if I want to do a prediction. So in other words, I could plug in a shoe print and predict height. All right, so that's that. Now, if I want to come up with a graph of this, so I would highlight all my data, and with regression, we definitely like the scatter plots. So you go to Insert, you go to Charts, and it's very important you only pick this first one right here. Okay, because these other ones will kind of mess it up. I mean, kind of see it's kind of weird looking. So I pick scatter. Now, when I look at this, it's like, well, this is okay, but why is everything over here? What I could do is I could change my axis to make this look a little better. So I right-click on the axis. I go to Format Axis, and notice I can change the minimum. I mean, I could probably look over here for the minimum value, but it looks like if I change it maybe to 22, that would be okay. And see, that kind of spreads it out a little bit more. I can do the same thing with this axis, so I can format this axis. Typically, you like your axis to start at 0, 0, but just so I can see this, so it looks like, you know, 150, 140 even, I could put in here. And it just kind of lets me see the data a little better. So I can certainly see a linear trend that this data, as X goes up, Y goes up. As height goes up, the shoe print goes up. And then in here, I can click on this little plus thing. and hopefully it'll show up. Sometimes it takes a minute to show these up, but I can get the linear, come on, baby. There we go. I can get my trend line on my graph, and so there it is. But if I go to the right here and I click more options, now I'm going to click this trend line options. Certainly this is a linear trend that I'm looking at, but I can also display the equation on the chart, and I can even display R squared value. So, and I can pick this up and move it where I can see it a little bit better. You can even change the size of the font and all that good stuff. But as you can see, this matches my equation. I mean, they just have it flipped around like the mx plus b. And this changes my coefficient of variation. So see, you don't even have to manually calculate those because you can get them automatically. All right, so let's kind of set my graph over here. Now I can do a regression analysis, so I can go to my data analysis. Remember, you had to add this. And I can go to regression. I can say okay, and I kind of cheated and did this beforehand, so let me clear all these values out here. This is what yours would look like. So I want my Y values, so I would click on that button so it allows me to select my Y values. I click on that button to get this back. My X values, I click on this up arrow, and then I select my X values. I don't select the labels, but if you do, you have to check that there's labels. And then where do I want to output this? I don't know, probably right there might be good enough. Maybe come a little over. I'm not sure if it's going to hide, but I can move my graph some more. And then I say, okay. All right, so from here, some things to notice. There's my correlation coefficient. There's my coefficient of variation. Okay, and I can widen this. So these values certainly match up. I can see my coefficient of variation. Those values match up. We'll make those dark green. And then some other things that I can look at here is, remember one of the things I mentioned towards the end of the lecture is that I can directly find my variation. So my explained variation is this 2.61628. And then my unexplained is this 1342.48. And then, of course, my total. So this column right here is my resulting variations. All right, another thing to notice is look at this. This is that value, which is also on my graph. I'll move you over here so we can see you. So that's the 80.93. So that's my intercept. And then there's my slope. So you can see you can find these values many different ways. I tend to not use these formulas, but sometimes students like to just do this very quickly. Maybe they don't want to graph it and they don't want to do a regression analysis. They just want the equation very quickly, and that's the only good part of just using these formulas. All right, now the hard part. The problem is all this good stuff down here with confidence intervals. These are not prediction intervals. So we want to do a prediction interval, which is what you see right here. Okay, so this is my prediction interval. Go ahead and kind of move that down. And I can find my t-value, and my standard error actually is right here, but I have to manually compute this piece. So what I do is I kind of get all my pieces ready because I can see I need a sample size. Well, that's okay, that's right there. I can see I need the average of my X values and the standard deviation. So let's just go ahead and get everything. I believe on the lecture I did a 95% interval, so my alpha would be 0.05. My t-value then would equal t dot inv. This is two-tail because it's an interval. My probability. Now here you have to be careful because the degrees of freedom is your observations minus 2. So I can either click here and do -2, or I can go to the residual, because that'd be 40 minus 2. Close the parentheses, and there's my t-value. So again, I'm just kind of looking up here everything I need. My standard error, let's go ahead and just move it over here. So I'm just going to do an equal and click on it. And what do I need next? I need n, which is my sample size, my number of observations. What do I need next? My x. If you remember in the video, we are predicting a shoe print of 29 centimeters. Okay, so that's my prediction, what I'm trying to predict. And then I have my standard deviation. So my standard deviation of my x values. I guess I skipped my average. So let's do the average first, and then we'll do the standard deviation. So equals the average of the shoe prints. That's my x variable. So you're good at that by now, right? Average. And then my standard deviation of my x variables. There we go. And so it looks like I have everything I need, but I'm putting an interval around y hat. Well, what's y hat? Well, that's this when I plug in my x value. So my predicted then y hat would equal, and this is kind of nice, or even scrolling down here getting these values, would equal 80.93 plus, I'm looking right here at this equation, my slope times the x value that I'm trying to predict. And so this would be my prediction if I plug in 29 into my regression equation. All right, so now if I look at this, you might say, well, that's going to give me 0. This is the problem with decimal places that I always tell students, don't round. If I increase the decimal, look at there. There's more decimal places there. So that's probably good enough, but this is why you reference Excel. Otherwise, you would have just gotten 0. Okay, so I see that I have my t. I see that I have my standard error. So let's just go ahead and do the formula for the square root piece. That way we kind of have it separate here. So I can see that equals the square root, open parentheses, 1 plus 1 divided by n. Are you following along right there? I'm using that. Plus, I want to open the fraction, open the numerator. Okay, so this is my numerator, and within my numerator, well, that's probably enough. Let's just say open my fraction, and then my numerator is going to be x minus x bar, close parentheses, square, divided by my denominator, which is the standard deviation squared, times, open a parentheses, where'd my n go? N minus 1, close the n minus 1 parentheses, close the denominator. You can kind of watch it where it's closing. Close the fraction, close the square root. Okay, so you just kind of have to be careful with those parentheses that you're grouping things. I hit enter, and that's the square root. So why not just go ahead and get E, which E is my t-value times my standard error times this square root piece. So that means my prediction interval, the low and the high. So the low, looking right here, equals my predicted value minus my error, and then equals my predicted plus my error. So the hardest part of this, because most of this stuff's easy to get, is getting this square root piece, okay? And unfortunately, Excel doesn't give you a way to give you your exact prediction interval, because if you look down here, that's not the same as the confidence interval. And so that would be my prediction interval, and I'd be done.